All right, our last objective for the fourth additional focus area on electrostatics is pretty short. It's kind of taking something we've learned pretty well and adding a little bit to it, but it shouldn't be too difficult for us. Electric fields. We've talked about fields in class. We're going to talk specifically about electric fields, what they are, how they work, and how to draw them. So the definition is just an electric field is the space around a charged particle, a positive or a negative, like an electron or a proton, where the particle can exert electric force on other charged particles. So just like with any vector, the longer the arrow, the stronger the force, whether it's pointing toward the negative particle or away from the positive. But those arrows tell you some things. So anytime, and this is super important, there are several questions that relate to this. Anytime you have a positively charged object or atom or molecule, you will draw arrows pointing away from it in an electric field. Anytime you have a negative molecule or particle or object, you'll draw arrows towards it. And that's why if these two objects come together, you can just follow the arrows. The arrow points here, the arrow still points here, so those two objects will be attracted. Remember, positives and negatives are opposites, so they attract and come together. And we'll show you some fields in the next slide of what happens if you would have two positives near each other or two negatives. And there we are. These are called interacting electric fields, meaning two fields come together. So when we have opposites on the left, a positive, we see this picture on the left, and a negative, the arrows always point towards the negative, we said, and away from the positive. So the arrows are both pointing towards this negative side, so that's why you see these electric fields kind of join together. Now, on the opposite side, it's just too far away, but you can even see those ones are bending some. They're just not able to be pulled. There's not enough force between them. If we have two positively charged or two negatively, as long as they're the same charge, we said with positive, the arrows always point away. Well, this is pointing that way. This particle is pointing that way, so they kind of collide and they push apart. So you can see those lines bend away from each other because they're moving in opposite directions there. So the biggest thing from this last little objective is to know that if we have particles that are having force vectors going away, that's positive. And if they're going towards it, it would be negative. So in this case, these are both positive. But again, positive, we said we draw arrows going away. A negative charge, we always draw the arrows, the vectors, the force going towards it. When those fields get close enough to each other between two particles, they have interactions. And if they're opposites, a positive and a negative will come together and attract. If they're two positives, like we see in this picture, they get pushed apart. They are pushed apart. Same thing would happen for two negatives. And that's really the only new thing we needed to talk about.